You can build a lot of things with 3D printing these days. This is a house going up, and you can see how it's being constructed. This nozzle is being fed with concrete, and it moves slowly across the building plane to form the walls and the infrastructure to build a house. If we scale that down quite significantly and use a plastic filament instead of concrete, then we've got something that's much more useful to us as railway models. This filament comes in a variety of materials and is fed into a unit called an extruder. This consists of a stepper motor to feed the filament and a heated nozzle to dispense it. Stepper motors also move the extruder in relation to the bed, in all 3 axes, all controlled by a special file fed to the printer. Before we can create that file, we need a model to print. So let me show you the process that I go through designing and building things for model railways. This is a ground signal, which is actually in 00 scale, that I'm designing for a friend of mine. He's actually planning on putting a printed circuit board in there with 4 LEDs on it, and then wiring to those up through the main shaft. As you can see, there's a way straight through there to get up to the LEDs. It'll be controlled by CBus. This is using Fusion 360. Fusion 360 is an extremely powerful piece of software. I've had it for about 9 or 10 months, and you can get it free for the first 12 months, so that's great. To my mind, there's little point in having a 3D printer unless you're actually going to design stuff and print it yourself. Because if you can come up with a design, you've got the whole process under your control. You can design it, you can print it, you can paint it, and you can use it. Let's have a look at this oval dining table just to give you an idea, just to give you a feel for how you can put things together using Fusion 360. There it is. Now, let me just show you how it was put together. Down in the bottom left-hand corner, there's a timeline down here. And this enables me to show you all the various stages. So if we go right back to the beginning, starting with a blank sheet. Let me just get rid of this panel on the side. Right. So the first thing I did was draw a sketch. There's the sketch, 1 circle and an oval. It's flat, it only has 1 plane drawn on the XY axis. What you can do next is extrude this circle out. So the next stage was to extrude it. So now we have a 3-dimensional cylinder sitting on the oval. So having done that, that's now the basis of our leg. Next thing to do is extrude the top. So there's our top. So we've still got our drawing there. We've simply extruded the 2 sketches. The next thing to do is to draw an oval. And there it is. I've centered it away from the central axis of the leg. And there's one of many tools in Fusion 360. One of them is actually shown up here on the top left. It's called Revolve. And what that allows you to do is either add to or cut away from an item, so that if I revolve that oval around the central axis here, it cuts out the whole area around it. So now we have our leg with some shaping on it. All that remains to be done now is to round off some of the edges. We want a bit of a bevel under that top edge, one under that bottom edge, and one here on the top of the foot. So that's the foot, that's the top edge, and that's the top of the top of the leg done. If I take the sketches away now, you'll see that what we've got is a 3D table. Next stage is to export that. And if you go up to File, Export, it's an oval dining table. Well, we hope so. And if you click on this box, right down at the bottom, it says STL files. Click the STL file because that's what you'll need for the next stage. What we have to do next is convert that 3D file into slices that the printer will recognise. First, we open the STL file in the program, in this case, a Prusa slicer, and we'll see an image of it on the bed of the machine. If it's small, we can zoom in on it and move it around. Resize it, rotate it in any direction, or even make sure it's placed on the bed. We can, if we need to, change many of the printer's parameters, like the temperatures for first and subsequent layers, but normally we just need to select the layer height from very small, which will take a long time to print, to thick and therefore faster to print. For now, we'll just choose a middle thickness. Next, we select the filament type and the machine we're using. Finally, the amount of infill we want, as the software will hollow out our model. Once we're happy, press the Slice Now button and the software will take us to the sliced version. Here we can see how much filament will be used and how long it will take, as well as being able to look at the layers so we can see any problems and inspect the infill. Finally, we export it as a file that the printer can use. Then you just load it into the printer and sit back while it produces the model. Depending on the filament used, the finished model can be strong, hard plastic, through to soft and flexible, like in this Merg level crossing servo mount coupling connector. The mounts themselves, like this dual semaphore signal mount, are easily printed. However, you can see the layers, and even though they can be reduced with finer nozzles and smaller layer heights, they will never disappear completely. This is the table I designed earlier, printed on a filament printer. When I started looking at 3D printing, I was very tempted to get a filament printer and work on this basis. But then I came across resin printers. Resin printers work on, again, a similar principle, but they use a liquid resin instead of the filament.
The really significant difference between a resin printer and a filament printer is that the resin printer only has one adjustable axis, and that's the Z axis. X and Y are provided by an LCD screen. First of all, you'll notice that the build plate is at the top, so we're going to build whatever we're going to make upside down. The base is on the build plate, and we pull out the model as it develops. There's a vat for resin, and the base of that is covered with an FEP, a FEP. This is a special type of plastic sheet. Underneath the plastic sheet is the LCD screen, and beneath that, a UV light source. When you start printing, the build plate falls slowly into the bath of resin and hovers a very small distance above the base of the vat. You can set that distance, but the normal sort of distance is about 0.02 of a millimetre. On the right is what the LCD display is showing, and on the left is the build-up of the model. Every time the resin is exposed to light, it solidifies through the gap in the LCD display. Then the build plate moves up, settles down again with a gap of 0.02 millimetres, and the whole process repeats. Here you can see the supports being produced. The whole process here obviously is speeded up and we have compromised a little bit. Our layers are significantly more than 0.02 of a mil. But nonetheless, I hope you can just see the idea of how the thing is building up. Now we're starting to actually produce the model. So we've got two axes produced by the LCD display, and the Z-axis produced by the movement of the build plate, which is driven by a stepper motor. So let's speed things up a little bit. And you'll see that what we've actually produced is a small coffee table. This is one I designed for my O-gauge layout.